Hello everyone. In this section, we continue to learn about the virtualization features. In the previous section, we introduced some features of this general virtualization from two perspectives, cluster perspective and virtual machine perspective. Then, Huawei's virtualization solution is a very good demand solution. What are its characteristics? In Huawei's virtualization products, if you want to implement these advanced features, you must first install tools for the virtual machine. The virtual tools contains two parts. One is kernel node hardware driver, and the other is the user node VM agent process. The virtualized platform determines whether the tools are running normally by detecting the state of the user state process. Only the tools and virtualized platforms can obtain the hardware information corresponding to this virtual machine, and it can complete functions such as snapshot, hot migration, online adjustment, or virtual machine specifications, and network card QoS. At the same time, the user mode VM agent is a process running inside the virtual machine. Through this agent, the virtualization platform can obtain some state information of the virtual machine, such as the virtual machine's IP address and the state of the virtual machine at this time. And some instructions can be sent to the virtual machine through the agent, such as shutting down or restarting the virtual machine. With tools, we can do these features or introduce the characteristics of the Huawei virtualization product from two perspectives. One is cluster and the other is virtual machine. The features of the cluster basically cover all common virtualization features, including basic features such as memory reuse. We talked about NUMA previously. Let's take a look at HA load balancing and IMAC. First, let's take a look at the HA. HA has been refined and divided into three areas. The first aspect, what should I do if the host has a fault? What should I do if there is a failure in the storage? What if the virtual machine itself fails? There are corresponding operations such as recovery on the original base machine, or HA virtual machine recovery, or simply do not deal with. Load balancing drivers a function called power management, which is mainly for this part of the server in this cluster. Everyone knows that in the data center, the electricity bill is also a big expense. It includes the power of the server and the electricity cost of the equipment of the server, such as air conditioning. Now we are paying attention to this green energy saving, so we have to find ways to reduce this power supply. For this purpose, we have power management. Specifically what it looks like. Let's take a look at this film. For example, normal time we go to work is 8:30 in the morning, and someone working overtime at night will work overnight until 9:30. So at 7 o'clock in the morning, we have to ensure that all of our business is up and running. At this time, the manager will guarantee server and the virtual machine on the server. The application inside and virtual machine should be able to run normally, and all the devices should be fully equipped to ensure that everything will not get stuck when using the application. At the 11 o'clock in the evening, the employees have basically gone off work. At this time, most of the applications are in the idle state, so the virtual machine is also idle. We do not need to open so many servers. At this time, the system will automatically migrate the virtual machines on the part of the host to a centralized migration to several servers according to the load situation. And then power off the hosts that do not have the virtual machines. Doesn't this save electricity bills? At the same time, if the server I powered off is centralized in the certain area, I can also power off some devices around the area at the same time. Next day, the server will automatically powered on, and then the virtual machine that was migrated to other hosts last night will be cut back. And then all the equipment will be fully loaded to ensure that our day is working properly. This is power management. The second one is also called load balancing, which is called DRS roles. The second role is divided into keep VMs together, keep VMs apart, and VMs to hosts. First, let's look at what is called keep VMs together. Let's take a look at this picture. If I migrated the first virtual machine to another host, and then another virtual machine on the same host will automatically migrate to the same host. This is called keep VMs together, which means to ensure that some virtual machines must run on the same physical host at the same time. What is this use? For example, some related applications, of course, are faster to call each other between the same server and do not need to be called across the host. In this case, we need to virtualize these types of virtual machine into the same crew to make them become keep VMs together. Keep VM apart is actually the opposite of keep VMs together. For example, if you migrate a virtual machine to one host, another virtual machine will automatically migrate to another host, and it will never be possible. Stay on the same host at the same time. Let's take another look. At this time, I migrate virtual machine to the host on the right side, and another virtual machine automatically migrates to the left side of the virtual machine. This is called keep VMs apart. The specific application is that there must be an application that is active and standby deployment. In order to ensure the high availability of the server, another virtual machine is not forwarded by a virtual machine. At this time, we will let the two virtual machines run on different hosts. Even if a host is harmed, I can guarantee that another virtual machine is not running on this host. It can be in a normal state and then continue to provide applications. The last one is VMs to host. VMs to host is associated with a virtual machine group and host group, and the association rule is set. The virtual machine is to be set in advance, added to virtual machine, and the host to be configured is also added to this. Inside the host group, then specify whether the selected members of the virtual machine can run on a member of a particular host. There are several rules for VMs to host. The first one must be run on the host group, and the second one is forbidden to run on the host group. One should be run on the host group, and another one should not be in the host group. There are so many rules for DRS, but there is a problem. What should I do if there is a conflict between the rules? I prefer which rules to call. Let's take a look at the product documentation. The latest version of the product documentation is clearly written in the search configuration strategy on the product documentation. What should I do with the priority of scheduling? What is the first priority? What's the second priority? What's the third priority? Let's take a look at the product documentation. The last feature about the cluster is called IMAC, which means that the virtual machine can be migrated on the host of different CPU types, but it also has some limitations. For example, the current iMac strategy only supports this Intel difference. The CPU of the model is host migration, and other manufacturers' CPUs cannot configure this function. Moreover, when implementing the iMac policy, if there are hosts or virtual machines in the cluster, the following two conditions must be met. The first is to cluster the host CPU functional level, which must be equal to or higher than the set functional level of the target reference. The second is the functional level of the CPU running in the cluster or the dormant virtual machine, and must be equal to or a functional level below to the target baseline. If there is a virtual machine does not meet the conditions, you need to move the virtual machine or migrate out of the cluster and then make these settings. Next, let's take a look at the features of Huawei's virtualization products. It also basically covers the characteristics of all common virtual machines, such as resource managers, faster deployment, and a console. The console supports VNC logging method in efficient compute, and there are also others, such as our most important snapshot, as well as some hardware device bindings. Let's take a look at the QoS of CPU and memory in the resource management. They are divided into three ways. One is quota, one is reserved, and one is limit. Quota distributed the total CPU proportionally to each virtual machine. Reserved determines a lower limit for the CPU and memory resources occupied by a virtual machine. What it means is that no matter what happens, the system must have enough resources. The limit is the upper limit that determines the virtual machine's CPU and memory resources. There are two questions about virtualization features. The first is about snapshots, and the second is a true and false question. This chapter mainly talks about two aspects. The first aspect is the characteristics of virtualization, and the second aspect is about the application scenarios of virtualization features. The content of this lecture is over. Thank you.